Okay guys, in this video we're going to be looking at the side-side angle case in which we use the law of sines, but looking at how we can determine if there would be a second valid angle or a second valid triangle or not. And so taking a look at this situation here, we've got a situation where we're given an angle and then we're given the side opposite that angle as well as one of the other two sides. And so if we were to sketch this out, it would look kind of like this here. Now I put this as a dotted line down here because I know that this angle here is a 50-degree angle, but it's the angle followed by two sides. So I know the two subsequent sides here, and these two subsequent sides would be these right here. If I'm calling this capital A, then this would be lowercase a, and in this case lowercase a is 6, and then B, this would be like, say, this vertex down here if it connects. But this is going to be our B right here, which is really the side adjacent to the angle that we were given here. But this angle side case, the question is going to be, can we even make a triangle in the first place? And if we can, if this actually does connect back over here, this 6 here, could it also make another triangle on this side? So here's what we're going to do. We're going to take a look at this angle side case, starting with setting up our little data information organizer. This is pretty important that you are keeping track of your data in this format, just because we're going to get possibly more than one solution in certain cases. So filling out what we know that A, capital A, is 50 degrees. We know lowercase a is 6, and we know lowercase b is 7. So in this case, we could say, first of all, can I use the law of sines? Well, certainly we have a side angle pair here, and this is pretty easy to indicate when you look at your data matrix over here. So because we have this side angle pair, we're going to go first things first, search for the unknown angle. So for the steps that we're going to go through to figure this out, number one, let's go ahead and read this first. It says, see if you're given two sides and the angle not between, or the side angle case, also the angle side, however you want to write it. It says this is the situation that may have two possible answers. So in this case, we can recognize that this is angle side if you draw it, but also because we have an angle side pair, but only one of the angles. Okay. So what we're going to do on step 2 is just find the value of the unknown angle. In other words, let's go solve for B here. So I'm going to go ahead and set up my law of sines. I know sine of capital B over lowercase b, which has a value of 7, would be the same as the sine of A, which is the sine of 50 degrees here, over the sine, or sorry, excuse me, over 6. So running our cross product here, we get 6 sine B is equal to 7 sine 50 degrees. And we would divide both sides by 6 to get our sine of B by itself. So we get 7 sine of 50 degrees all over 6. Now, to get to our B, of course, we need to take the sine inverse of both sides. So we get the sine inverse of 7 sine 50 degrees all over 6. And now we can go get an angle for this right here. So to find this unknown angle, I'm going to get my calculator out here. Now I already made sure I was in degrees mode, so it'll tell me in degrees what the angle is. But I'm going to start with the inside of this. I'm going to do just 7 times the sine of 50. So our 7 sine 50 is this. Now I'm going to take this and divide by 6, which gives us about 0.8937, yada, yada, yada. Now this goes on forever and ever. So if I'm going to take the sine inverse of this, I actually have to hit sine inverse and then of my answer. So answer, remember that's behind your negative key here. We'll hit second negative key. But we get about a 63.3 degree angle. Now to keep things simple, I'm going to say that B is approximately 63 degrees. So we're going to go ahead and take this, and of course we would put this back up here in our data matrix, data organizer, but we would also label it on our triangle here, 63 degrees. The thing is, because this worked, it means that if you're an angle side case and you get one angle that works, then there's possibly a second triangle that works. So for the third step here, once you find that angle, it says once you find the value of your angle, we're going to subtract it from 180 degrees to find the possible second angle. So what I'm going to have everybody do is basically, let's go ahead and extend this here, and we're just going to refill this out. We're going to fill it out again, and we're going to fill this out as if this is the second possible triangle that could exist in this particular case. And so filling in what we already knew, we knew this was 6, this was 7, we knew this was 50 degrees, but in order to get this angle here, what this is saying is we're just going to take 180 minus the angle we just got, which in this case comes out to be 117 degrees. Now, I will write the 117 here, but it's always important to me that you write 180 minus the angle you just got up here. The question is going to be, can this possibly work? Now, if you read step number 4 here, or the fourth thing we need to check, it says, take your new angle and add it to the original angle. So that is to say, I'm going to take my 117 degrees here, and I'm going to add it to my 50. Now, the reason why we're doing this is going to become intuitively obvious. What we want to determine is, could angle C even possibly exist? So what you'll notice is that the 50 plus the 117 adds up to 167, and if all of our angles add up to 180, means that basically we have 13 degrees left over in this angle C here. So what we're really checking for is this. We say part A, if the sum of the angle you just got here, the 117, and the original angle, if that sum is less than 180, then we have two valid answers, and that's because we had 13 degrees in this case left over here, or we had some degrees left over in that last angle. But if the sum is over 180 degrees, then what we would just do is this. We would say over 180 degrees, the second triangle doesn't exist. In this case, it certainly does exist. So what we're going to do is go ahead and finish solving both of these triangles, but know that this second triangle works here, and our first triangle also indeed works. So to solve the first triangle, let's go ahead and do this. We say 50 plus 63, add those up. So 50 plus 63, we get 113, and if we take that away from 180, I'm just going to take 180 away from it, we get 67 degrees left here in this back corner. So to solve for little c, let's go ahead and set this up. We say c over the sine of 67 degrees in the first triangle here would be the same thing as 6 over the sine of 50 using our original side angle pair. And so running our cross product here and solving for c, I'm going to shorten up my work a little bit here, but we get 6 sine 67 degrees all over sine of 50 when you do your algebra there. And so let's get a value for this. So 6 sine 67, enter, divided by the sine of 50. What we get for our first triangle is that it's about 7.21 units long on this side here. And in terms of reasonability here, these two angles were very close. Well, so were these two side lengths opposite. Excuse me. So very certainly reasonable. Now, looking at C in the second triangle, we say C, this time though over the sine of 13 degrees, would be the same thing as 6 over the sine of 50. So again, we would run our cross product here. We get C sine 50 equals 6 sine 13. But what we end up with is really 6 sine of 13 divided by that sine of 50. And so this is our exact value here for C in our second triangle. And the way I would write this, or at least what we get for a value, is 6 sine 13 divided by the sine of 50. And in this possible case, we get about a 1.76 length side. 1.76 units in length, and that makes reasonable sense also just because this was by far the smallest angle of rotation that this shortest side length was opposite. So if you ever have an angle side case, you solve it just like you normally would, but the moment you get this angle, to set up the second triangle, we just take 180 minus that original angle here and get this angle there. Now if the second triangle works, remember that there's going to be leftover degrees that can fit an angle C here. But if the second triangle doesn't work, then when you add up this original angle plus this new angle that you got by subtracting it from the original angle from 180, if it's more than 180 there, then you're going to say no second triangle exists and there's only one solution. Cheers.